Hi, I'm Will. I work at Applied Engineering at NVIDIA, and I'm going to be showing a demonstration using MAXIMUS technology. MAXIMUS is a technology that lets us use the Tesla card for simulation and compute, and use the Quadro card for rendering. In this example, I'll be showing fluid dynamics, which allows Maya users to achieve new levels of interactivity. So traditionally in Maya, you would work with N particles. So here's an example of pouring N particles over some collision objects, which are just spheres. And you can see that the system has now become severely compromised by all these particles. And when I say all these particles, I'm referring to a particle count of 8,000. So if we switch that over to NVIDIA accelerated particles, this is using the CUDA programming environment, we can pour close to 200,000 particles without any loss in interactivity over the same spheres. And you can see the system is running completely fluidly. It's hardly affected by the amount of particles that we're pouring out. So what does this mean? Well, when we have this level of interactivity, we can do some really interesting things. So here's a scene where I'm going to be pouring fluid into this box. Because the Quadro processor isn't having to do any simulation, it can be used to render the fluid really nicely here. So we've got some transparency, you can see it's refracting the wireframe underneath. We're pouring it into a box that's sloshing about, all in real time, and we can still interact with it. What we can also do is we can apply a height field to that box. And the height field is simply an image. This image is the NVIDIA logo. So you can see the water now falls into this displaced surface, all still completely interactively. We can also use Maya's traditional tools and fields, force fields, emitters, and so forth, to interact with the fluid. So here, I'm going to change the magnitude of this radial field to pull the fluid towards me. I can also push it away from me to the sides of the box. There is absolutely no chance that you could do this with traditional particles. The fluid dynamics is done with something called smooth particle hydrodynamics. In this example here, I'm going to be showing a pier where the waves are simply pushed into this beach scene. You can see the water correctly colliding with the piers, draining back past the piers to create interesting shapes on the sand. And you can also see the water creating correct arch as the wave crashes in and collides with itself as it drains back. None of this would be possible using Maya's traditional particle systems. Finally, in this example, I've created a surface which is a displaced map from a digital elevation model. We're pouring particles from an emitter at the top, and you can see the water correctly pour down into the valleys through all the crevices to form a lake down at the bottom. It's also colliding with the buildings, still remaining completely interactive. As well as rendering it as a fluid, we can also render it with more diagnostic means. This shows the color as we're emitting from a textured surface. We can show the velocity, or we could show the pressure. At this point, a radial field has kicked in, and now the particles are being attracted to a point to create some kind of fluid monster. So this technology can radically change your particle workflow. Whereas before you'd have to simulate and render on a farm, which could be very costly, now you can see all of this on your desktop interactively. You could even work with this in motion capture. And all of this is because of the MAXIMUS technology. Simulation on the Tesla, rendering on the Quadro.